Welcome to Equations, lesson number 3, two-step equations using opposite operations. This is a continuation of lesson number 2, where we were using opposite operations to solve equations. The difference is that when we're solving equations that require more than one step, we need to make sure we're doing our operations, our opposite operations, in the correct order. So let's have a look at that banner again. That banner here says that yes, addition and subtraction are opposite operations. What's new is that we are going to be completing those opposite operations first. So no matter what's happening to our variable, we're going to undo addition and subtraction first. That's followed up by yes, multiplication and division are opposite operations, and we complete those opposite operations second. All right, let's have a look at example number 1. Example number 1 says solve the following equation. 2a plus 3 equals 7. Let's start by finding our variable. There it is right there. That's an a. Now two things are happening to our variable. The first is it's being multiplied by 2, and then it is having 3 added to it. So each of these represents a step that must be undone on our path to isolating a all by itself on the left side of our equation. So at the end we're going to have a equals something. We have to undo these two steps in the proper order before we get to that a equals something. And the first step that we're going to undo is going to be subtract 3. So what's the opposite, or rather add 3. What's the opposite operation to adding 3? We're going to subtract 3. And to keep this equal, we're going to do it to both sides of our equation. So on the left side of our equation, plus 3, subtract 3, those have undone each other, so they're no longer around. We have 2a remaining. And on the right side of our equation, we have 7 minus 3, which gives us 4. So now, one step down, another step to go. What's still happening to a? A is still being multiplied by 2. And what's the opposite operation to multiply by 2? How do we undo that? We are going to divide by 2. But again, to keep it equal, we need to divide both sides by 2. This multiply by 2 and divide by 2, they have undone each other, leaving us with an a on the left side of our equation, and 4 divided by 2 on the right side gives us 2. So we've come up with an answer. Now we need to check it. We're going to write out the left side of our equation. This is our formal check. We have 2a plus 3, and in the next line we are going to substitute the value we believe a to be equal to, which is 2, into the equation. And now we're going to do BEDMAS. We're going to actually solve or evaluate this expression using the proper order of operations. So we're going to do the multiplication first. 2 times 2 is going to give us 4 plus 3. That's going to equal 7. So that's the left side. The right side, when we look back up at the top, is also equal to 7. So when we look at the values for the left side and the right side of our equations, they are the same. So we can say, therefore, the left side equals the right side, and happy face, because we got the right answer. So this is how you solve an equation with 2 steps using opposite operations. Let's try another one together, and then we'll see how you do on your own. So here is our next example. We have c divided by 3 plus 4 equals 9. So there's our variable, c. 2 things happening to c. It is being divided by 3 and having 4 added to it. So we want to undo the addition and subtraction first. So what's the opposite operation to adding 4? It's going to be subtracting 4. So I'm going to write that just underneath, and I'm going to write it on both sides since we have to maintain the equality of our equation. So this operation, adding 4, subtracting 4, they have undone each other. We're left with c divided by 3 on the left side of our equation, and on the right side we have 9 subtract 4, which is 5. So we still have c being divided by 3. How do we undo divide by 3? What's the opposite operation to divide by 3? It is to multiply by 3. But we need to do that to both sides of our equation to maintain equality. So these two operations, multiply by 3, divide by 3, they have undone each other. That leaves us with c equals 5 times 3, which is 15. So let's see if we can squeeze a little check in here. We'll get the left side of our equation is equal to c over 3 plus 4. The value we believe is true for c is 15, so we substitute that in. 15 divided by 3 gives us 5 plus 4, and 5 plus 4 gives us 9. So there's the left side of our equation. Let's have a look at the right side. The right side of our equation is equal to 9. So on closer inspection, 9 on the right side, 9 on the left side. Therefore, left side equals right side, and happy face. We've got the right answer. C is indeed equal to 15. So what I'd like you to do is hit pause here in the video, and I'd like you to give B a try on your own. Find a value for D that makes the left side equal to the right side of our equation. So hit pause. When you got an answer, including your check, come on back and we'll see how you did. Okay, there's our variable D. It is having two things done to it. It's being multiplied by 4 and having 1 subtracted from it. We're going to undo addition and subtraction first, meaning that we are going to undo subtract 1 by adding 1 to both sides of our equation. Those two operations, subtract 1, add 1, they have undone each other. And on the left side of our equation, we are left with 4D equals 11 plus 1, which is going to be 12. Now, how do we get this D all by itself? Well, right now it's being multiplied by 4. The opposite operation to that is divide by 4. But we need to do that to both sides of our equation to keep this equal. Those two operations, multiply by 4, divide by 4, they have undone each other, giving us D equal to 12 divided by 4 gives us 3. So let's get a little check in here. The left side of our equation is equal to 4D minus 1. We're pretty sure that D is equal to 3 minus 1. That's 12 minus 1. That's going to equal 11 on the left side. The right side is equal to, we'll go up and have a peek at it, it's also equal to 11. So we're taking a look. 11 on the right side, 11 on the left side. Therefore, the left side equals the right side. Happy face. Whoa, that's not a happy face. That's a happy-ish face. So that is the end of lesson number 3. By all means, have a look back to the video. If you're not 100% sure of the steps, head off to the worksheet and we'll see you in lesson number 4.